All right, guys, hopefully you have out your SAB, and we're going to do this next lesson in two parts. So we're going to do 8-8, which is classifying quadrilaterals, in two parts because it just felt a little tight to try to do it in 15 minutes. So this video and tomorrow's video might be a tiny bit shorter, but that's just because we're splitting up one lesson amongst two. So let's go ahead and get started. You should have out your 8-8, and today we're going to talk about quadrilaterals. I'm not totally sure exactly what you remember from the past. Obviously, this would be easier if we were doing it in person, but we're not. So, a quadrilateral is basically any four-sided shape, but anything that is a polygon has to be closed. So when I say I should say four-sided closed shape. So for example, this is technically a four-sided shape, but it doesn't close, so not a quadrilateral, okay? So a quadrilateral has that's one name for a four-sided shape, but then there's more specific ones, which we're going to learn a little bit about today. But first I want to talk to you about something called adjacent and opposite, which are going to talk to you about the sides of your quadrilaterals, and so we need to jump into those. So this says, in all of the quadrilaterals, the sides are labeled, these sides labeled A and B are adjacent to each other. And then the sides labeled B and C are also adjacent to each other. So think about what you think adjacent means. If they're telling you that A and B are adjacent to each other, and that then also B and C are adjacent to each other, what do you think that might mean? Hopefully you thought that that meant that they're touching, right? So they meet together at some magical little point right there. So I'm going to come down to this page. I moved this little picture off to the right so we can still access it, but now we can see what the questions are. So number one just asks you, what do you think it means for two sides to be adjacent? And we're going to kind of summarize what I just said. So I think it's when your two sides meet at a point. Two sides meet at a point. Okay, so again, A and B are adjacent, B and C are adjacent, C and D are adjacent, and also D and A are adjacent. Now, unfortunately, B and D are not adjacent, and A and C are not adjacent. So it says which other sides are adjacent to each other, the ones that we just mentioned. So we could say C and D, D and A, and I think they had already mentioned B and C, but we'll just put it on there as well, B and C. So those are all the sides that are adjacent to each other. All right, now we've got another word to talk about, which is opposite, which I'm pretty sure I can guess that you guys probably already know what that one means, but let's still talk about it. In all of the quadrilaterals, the sides labeled A and C are opposite each other. So we've got A and C, we've got A and C, A and C, and then A and C, right? So it says, what do you think it means for two sides to be opposite each other? And then we would basically just say they're across from each other. And the most important part is they do not meet at a point. Do not meet at a point. So then what would be our other sides that are opposite? That would be D and B, or you could have said B and D, doesn't matter. So opposites and adjacents, those are going to be important. Those will be words you'll hear me say a little bit, but they're kind of important ones. So I'm going to show you the directions first, and then I'm going to talk you through the work we'll actually do today. So this says, this is kind of what I was mentioning at the very beginning. So some quadrilaterals are special because they have parallel sides or right angles. You already know about rectangles and squares, and other types of quadrilaterals are the trapezoid, the parallelogram, and the rhombus. And it says you can list each type and describe its sides and angles. So I just want to show you, this is what's on the next part of your page. But first I want to come back here and I want to just talk about something a little bit more in depth. So here it says some quadrilaterals are special because they have parallel sides or right angles. So let's do a quick reminder. Parallel sides are your lines that go on forever and they'll never meet in the middle. And a right angle is that perfect 90-degree square corner where if you were to use a protractor, you would measure 90 degrees. If you were to use a little scrap piece of paper, it would also be exactly 90 degrees. And then it says you already know about rectangles and squares, but let's just remind ourselves. A rectangle is something that has two opposite sides that are parallel. So these two sides are parallel and these two sides are parallel. And we also have got a whole bunch of 90-degree angles at each of its corner. And then these two sides are the same length, and then these two sides are the same length. Well, the same is actually true for a square. It's got all the things that I just mentioned, except for the thing that it also has is that all four sides are the same length, and that's really important to know as well. Okay, so let's dive into trapezoid, parallelogram, and rhombus also. At the top of this chart is showing you that everything we're talking about down below here is basically a quadrilateral that has exactly four sides, and it also has exactly four angles. So I'm going to highlight in blue for you your four sides. So this one has 1, 2, 3, 4 sides. And then I'm going to circle in red your angles. This creates an angle, this creates an angle, this creates an angle, and this creates an angle. So if I were to use a protractor and I were to measure all four of these angles, no matter what I did, as long as it's a quadrilateral, they will all add up to be exactly 360 degrees. You don't have to know that for sure right now, but I just wanted to help you with that in the future, that they're all going to equal 360 degrees, okay? So a parallelogram, a trapezoid, a rhombus, a rectangle, a square, they all equal 360 degrees. Oh boy, my dog is really freaking out. Okay. Now I'm actually going to erase some of this stuff because what I also want to show you is that this is a quadrilateral, but it's got a lot going on. There's not really any sides that are parallel to each other. It also doesn't have necessarily any sides that are the same length. So a quadrilateral truly and honestly is anything with four sides and four angles. It doesn't have to have any of these other qualifying things. But let's talk now about some of these other shapes. So I'm going to look now at parallelogram. I'd like you to do the same. So a parallelogram is a quadrilateral, but it's a special kind of quadrilateral because it not only has four sides, but it also has two pairs of opposite sides that are parallel. So for example, these two sides are parallel, and then these two sides are parallel. So if we were to keep going on forever, those two sides would never, ever, ever intersect, the two blue sides. And then if I were to go on forever here, these two green sides would never, ever intersect, okay? I'm going to delete that a little bit. But a parallelogram doesn't have to look exactly like this, but that's how we know that it is truly a parallelogram, is when it has those four sides and it's got two pairs of opposite sides that are also parallel. Okay. Now here's something that's going to be really interesting for you to notice. A rhombus, a rectangle, and a square, they're also parallelograms. So not only are they quadrilaterals, but it's also a parallelogram. It's just that it has a more specific name, so we call it by its more specific name, okay? So for example, now I'm going to talk to you about a rhombus. You've probably heard a rhombus called a diamond before as well. You might have even called it a kite. They're all the same thing. They're all considered to be a rhombus, okay? So a rhombus has four sides. Although, no, sorry, kite's a little different. Anyway, a rhombus has four sides, just like a parallelogram, just like a quadrilateral. And it has two pairs of opposite sides that are parallel, just like our parallelogram. But what's more specific about a rhombus is that it also has four equal sides. So yes, these two opposite sides are parallel, and these two opposite sides are parallel. But also, if you were to get out a ruler and measure all of these, they would all four be the exact same size. Okay? Now, we have another kind of parallelogram that also happens to be a quadrilateral, and this time it's a rectangle. So a rectangle has those four sides. It's got two pairs of opposite sides that are parallel. So this is parallel to this. This is parallel to this. But the thing that makes it more than just a parallelogram is that it also has four right angles. That's something your rhombus is missing. A rhombus does not have four right angles. Instead, it's got two acute angles and two obtuse angles. But this rectangle has four right 90-degree angles. So its more specific name is a rectangle, although it is technically a parallelogram, and it is also technically a quadrilateral. Now the last one of all is the square. The square is the coolest because it's got all of them. A square has two pairs of opposite sides that are parallel. Boom, 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 boom. It's got four right angles, if you were to draw those in there. And if I were to measure all four sides and they were all 1 centimeter, that means all four sides would be 1 centimeter. okay? And then we have this other kind of funky quadrilateral. It's called a trapezoid. It's still a quadrilateral because it has 4 sides, but that's as specific, or that's the only thing that it has in common with anything over here, because since it doesn't have more than one set of parallel lines, it can't be a parallelogram, which then can't be a rhombus or a rectangle or a square. So a trapezoid truly only has one set of parallel lines. So for example, this one right here has parallel lines right there. A kind of a funny trapezoid that you can draw is also called a right trapezoid. And this one's kind of weird because it's got 2 right angles, but it still has all the other same things. It only has one set of parallel lines, and it only has 2 right angles, not all the other stuff. Okay? So to finish us out today, we're just going to do 5, 6, and 7. This says draw a quadrilateral that has exactly one pair of opposite sides that are parallel, and then it wants to know what type of quadrilateral it is. Well, you can go back and look at this paper that yours probably isn't drawn all over. But for me, I know that one pair of parallel sides is automatically going to be a trapezoid. So then off to the right, my job would be to draw something that has one set of parallel lines. Why don't we go this way? So I'll make this parallel to that. You can see that they're not the same distance apart, which is great. And then I just need to connect this side to there and this side to there. So I've just created a trapezoid. Yours is okay if it looks different. Just make sure that this line, which is parallel to this line, is not the same length. Let's look at number 6. It says draw a quadrilateral that has 2 pairs of opposite sides. They're parallel. And then it says, what type of quadrilateral is it? Is there more than one answer? So this kind of depends on what we draw here. If I were to just draw a parallelogram, maybe something like that, my job would be to ask myself, so those don't all look like they're the same length, but instead it definitely looks like it's a parallelogram. But what they're giving you an example of is if you had chosen to draw something with 2 pairs of opposite sides that are parallel, you could have also drawn maybe a square, or you could have drawn a rectangle. It doesn't matter. Those still have 2 opposite sides that are parallel. Mine doesn't totally make a rhombus, but you could even try to draw a rhombus too, okay? And then number 7 says draw a quadrilateral that has 2 pairs of opposite sides that are parallel. It has 4 equal sides and no right angles. So that's the one. No right angles is your big hint there. Does anybody remember what that one is? Hopefully you remember that that's called a rhombus. And then in order to draw a rhombus, you kind of just want to make sure that you're not drawing. So what I did is I kind of went over 2 and down 1. So I'll come over here and I'll go over 2 and down 1. So I'm going to try to connect those 2 lines together. And then those should all be the exact same distance apart. So there's my rhombus, okay? Now, for your example or your assignment today, there's no more SAB pages that I want you to do. We're doing the other problems together tomorrow, so no SAB option. And your homework and remembering is fine. The only problem is you're only going to be able to probably do about half of it. So my better example for you or my better advice for you on what to do for your homework today or for your extra practice would be to do some IXL from your weekly plan because we're not ready for some of this other stuff yet. That can be something you finish tomorrow, okay? All right, guys, best of luck.